These 6 processes of soil formation and development that we've just talked about lead to the development of characteristics within the soil profile. In order for us to be able to go in and use taxonomy, that is a classification system to identify these layers within the soil profile, we need to have a basic understanding of how horizons and subhorizons are designated within the soil profile. Major horizons in the soil profile are called master horizons. Master horizons are indicated with large capital letters. Those capital letters which are used are O, A, E, B, and C. And sometimes, if we're talking about a very shallow soil profile, we may find the letter R used. The letter O indicates an organic horizon. An organic horizon being one that is dominated by partially decomposed organic material where there's very little mineral matter. These types of horizons are typical not in cultivated soils and also rarely found in grassland soils. So O horizons are much more typical in a forested or permanent vegetation type of environment where we have heavy deposits of organic material or litter on top of the soil. The A horizon is the first of the mineral horizons and is sometimes commonly referred to as the topsoil. Topsoils, or A horizons, are indicated by high levels or accumulation of organic matter. This organic matter has been decomposed to a fine enough state or into the humus portion, though, to where it simply imparts a black color to the soil, and we are not seeing the actual presence of the plant materials from which that came. E horizons may or may not be present in a soil profile. The E horizon is called an alluvial horizon, or it is a zone where we've had a movement of materials. Typical there would be such as the movement of fine clays down to a deeper depth, or a movement of more soluble mineral material such as lime from upper layers of the profile down to deeper depths. The B horizon, commonly referred to as the subsoil, this is a zone where we oftentimes see maximum accumulation of materials that have been alluviated from above. Also, typically we have a lower organic matter content than the A horizon, and typically a higher clay content than we have in the A horizon or topsoil above. The C horizon is also normally not seen on the monoliths or the depictions we have here in the lab with the soil profiles. C horizons lie just beneath the true soil. They are heavily oriented by rock and mineral matter in an unconsolidated state. And as I mentioned before, although I don't have it on the board, if you have an R horizon, this is basically the bottom. This is the bedrock or consolidated type of parent material from which the soil is forming or has formed if it is a residual soil. Oftentimes we'll have breakdowns of major or master horizons into what are referred to as subhorizons. Subhorizons are indicated with lowercase letters written below and to the right of the master horizon. So for example, we could have a B horizon divided into a 1 and 2 or a B 1, 2, and 3. This is basically telling us that we have all of this as B horizon or subsoil, but we need to divide it into segments or portions because there are differences in color, structure, or something that indicates minor differences within a given master horizon. Very commonly occurring in soils, especially in mollisols such as the ones we'll look at in the lab today, are what are referred to as transitional horizons. Transitional horizons are where we are gradating from one horizon into the next, and that specific zone in the soil profile has characteristics of both of those horizons. So for example, I've written here on the board the letters capital A and capital E. The capital A would indicate the topsoil, the capital E would indicate the E horizon or zone of alluviation. So if we have an AE transitional horizon, we're basically saying that this is a zone between the A and the E horizon, dominated by characteristics of the A, but also having some characteristics typical of the E horizon. Another example I've written here would be an EB. This would be a transitional zone or horizon which occurs at the base of the E and the top of the B horizon in the soil profile. And then finally, we have what are referred to as subordinate distinctions within master horizons. This is where we can become much more specific about what has been the cause of that specific type of layer to occur within that soil profile. And I've written a couple of examples up here. Subordinate distinctions within master horizons are indicated by lowercase letters written to the lower right of the larger case letter indicating the master horizon. So for example, here we have an A sub P. What that A sub P is referring to, this is topsoil, it's A horizon, but this specific layer has been developed as a result of plowing or some form of cultivation. So an AP horizon would be where at the top of the A horizon we have a zone of cultivation that may be 6, 8, 9 inches in depth. Soils have been constantly mixed there as a result of cultivation, and it's caused somewhat of an artificial horizon to develop within the profile. We indicate that with an A sub P. If another example would be if we were down in the B horizon, we may have a B sub T. The B is a subsoil horizon, but within that we have a zone indicated by a maximum accumulation of alluvial clay. That is saying that in that B horizon we have a zone of clay that has been deposited there from alluviation of materials above, and then here we call it alluvial clay because, remember, alluvial, ILL, is a zone of accumulation where it redeposits again. If we were to have such a horizon occurring within the B horizon of the profile, we would use the subordinate distinction B sub T to indicate that type of formation within the soil profile. So with this introduction of soil forming processes and soil profiles, horizons, and distinction, or how we designate horizons within the profile, what I would like to do next is to have you refer to the page in your lab handout where there are 2 tentative soil profiles sketched in.